This video is going to go through the Honors Algebra 2 District Assessment Review at Quince Orchard High School for marking period number 1. The first group of problems we have ask us to find the average rate of change between 2 points. As a reminder, average rate of change is the same thing as slope. We have our formula for slope right here. And I also would suggest you open a window with the Desmos calculator. Please make sure you are using Desmos Scientific and not the Desmos graphing calculator. You will not have access to a graphing calculator on the test, but you will have access to a scientific one. So what we're going to do for all of these problems is we are going to set up the first point and the second point, and we are going to follow the formula for slope, which is y2 minus y1 over x2 minus x1. So you can see in this first problem, y2 is 2. So we're going to do 2 minus 4 divided by x2 minus x1. Now I want to make a note that the directions say your answer should be correct to 3 decimal places. So now I'm going to go ahead and grab my calculator and I'm going to do 2 minus, well, I know that's just -2. So now I'm going to say 5.239 minus 81, oops, 708. Okay, and so now I know the numerator here, I know that this is just -2. I wish there was a way to make that stay on top. So now I'm going to do -2 divided by, and then I think if I just click that, oh, can I make that happen? I'll just type it in. Oh, answer, there it is, answer. Oh, and there it is. So my answer is -6, -0.6366. I'm going to write that down. So I have an answer of -0.63. Now, the reason I'm writing it down to 4 decimal places, because it says 3 decimal places, is now I need to make a rounding decision. So because this number is 5 or above, I'm going to write my final answer as -0.637. I'm going to round this up. We go to the second problem. I'm going to label x1, y1, x2, y2. And now I'm going to set up y2 minus y1 over x2 minus x1. I really hope I can fit this. Okay, now I'm going to grab my calculator, and I know this one is 2.6. I don't know what the bottom one is. So let's see. Clear. We have 5 point, oops, 5 point, oh, 5.8, 35398 minus, okay, and so now I've got 2.6 is divided by that answer. And so I've got 0.8376. And again, because I have a 6 here, I'm going to round it up, and I'm going to report my final answer as 0.838. Okay, let's do 2 more. My suggestion, if you watched me do those and just wrote things down, is that you pause the video and now you try these 2 on your own. So I'm going to set them both up. We've got x1, y1, x2, y2. We've got 2.8 minus 0.02 divided by 1.141, 5, 9 minus negative Right? Oh, whoa, I wrote this wrong. This is 0.2. So I know that the numerator is 2.6. Grab the calculator. And now I'm going to do 1.1. Wait, clear. 1.1. I don't know what that was. 6159. So I know minus negative is going to become a plus. So I'm just typing in a plus. Okay. So I don't know what this noise is, but it's a little amusing. Someone must have a window open. So dividing by, stop it. 1.57078. Okay, so now I'm going to go 2.6 divided by answer, and I get 1.6552. Okay, so again, I look at the 2. The 2 tells me to round down, so my final answer is going to be 1.655. Again, if you've just been following along, you really need to pause the video and try this on your own. If you've tried it on your own, I'm going to label my points, x1, y1, x2, y2, y2, minus y1 over x2. I'm going to use my calculator off screen because honestly, I'm tired of switching back and forth. Well, the first one I can just do without. This is just -2. And this is 3.14159. And my calculator off screen. When I divide that, oh, again, when I go to round it, I look, I see a 6 here. That's going to tell me to round it up. So I've got -0.637. Okay. On the next page, the directions say, write an equation for the inverse. Well, the first thing I'm going to do is I'm going to do a mapping. So for letter A, I see the first thing I would do is cube. Then I would multiply by 6. Then I would add 7. To undo this, the first thing I would do to build the inverse is I'm going to go x minus 7, because the opposite of adding is subtracting. The opposite of multiplying is dividing. And the opposite of cubed is cube root. Okay. So there is my first inverse function. Now for letter B, when I before I map it out, I see this negative here, and I'm going to rewrite this as -1 x squared plus 10. Now when I map this out, the first thing we're going to do is square. Then we're going to multiply by -1. Then we're going to add 10. So when I go to build the inverse, the first thing I'm going to do is subtract 10. Then I'm going to divide everything by -1. Now I can actually do that. That gives me a nice pretty integer. So I'm going to go ahead and make this -1x plus 10. Then the opposite of squaring is to square root. So my final answer in purple here is f inverse of x is the square root of -1x plus 10. For letter C, it's a pretty simple equation. The first thing we would do to x is multiply it by 1/2. And then we would subtract 8. When we undo that, ooh, that was wiggly. The first thing we would do is add the 8. And then we would divide by -1 or by 1/2. Now, we can actually do this. I can do this by multiplying by the reciprocal. So I'm going to say x plus 8 times 2 over 1, which is the same thing as multiplying by 2. So the inverse becomes 2x plus 16. Number 3 says find the domain, range, or the endpoint, the domain, and range for each function. I'm also going to pay attention to what's in front of the root. I know that a regular square root function looks like this. I know this is what my square root function looks like. So the first thing I'm going to do is I'm going to find the endpoint. I see that the first graph goes left 1 and down 8. So the endpoint is going to be -1, -8. Now, there's no negative sign in front here. So I now know that this graph, pretend this is just oh, that's kind of a bad picture. If I go left 1 and down 8, just pretend this is left 1 and down 8, I know my graph looks like this. That means I'm going to have a domain of x is greater than -1 and a range of y is greater than or equal to -8. Now for the next one, for g of x, I see that it goes right 5 and up 2. So 5, 2, so it goes right 5 and it goes up 2. And here's the endpoint. The difference here is because we have a negative in front, it comes down. We have a reflection over the x-axis. So the domain is going to be x is greater than or equal to 5, but the range is going to be less than or equal to 2 because it goes down from the endpoint. H of x goes right 4 and down 3. No reflection. So right 4 and down 3, like right 4, down 3, endpoint. The graph just looks like this. So x is greater than or equal to 4. Y is greater than or equal to -3. If you've been following along at this point, you really need to pause the video and try the next one by yourself. Okay, I see this graph goes left 3 and up 7. And it also has a reflection. So it's going to go left and up. So here's my endpoint, left and up. And I know this is -3, 7, which obviously is not to scale. And it reflects, so it's going to come down like this. My domain is going to be everything greater than or equal to -3. And my range will be everything less than or equal to 7. Number 4 says, rewrite each exponential statement with a radical. Your answers should not contain any exponents. So the first thing I'm going to do is pay attention to what the exponent is on. So for letter A, I see that that 1/2 is only on the x. And I know that a 1/2 power is like a square root. So it's just going to be -4 root x. For letter B, I have a 1/3 power, which is like a cube root. And here, it's on the whole thing, the whole 2x. The negative is not in the parentheses, so it is not going to be in the root. I don't know what happened to the numbering here. It got a little wacky. So this is C. I think I got auto numbered on Microsoft Word. Rude. For letter C, I want to be really, really careful. Again, what is the exponent on? It is just on the x. So that -6 is just chilling in the wind. Now, I noticed that the exponent is a negative exponent. And because it has a negative exponent, it's going to go into the denominator. So it's going to be -6 over. The negative goes away, and the 1/3 becomes a cube root. At this point, you should pause the video and try D and E on your own. All right. Letter D is kind of similar to letter B with a little splash of letter C. The exponent is on the 7x. So the whole 7x is going to be under a square root. But because we have this negative exponent, it's going to need to go in the denominator. So the question really becomes, what goes in the numerator? Well, there's like a 1 here. So the numerator is going to be -1. And the square root is going to go underneath. So my answer is going to be -1 over the square root of x. Letter E, the 1/3 is just on the x. So we have -3 times the third root of x. Question 5 tells me that a graph of f of x is shown below. On the same grid, sketch the inverse function and then complete the table. So before I go to sketch the inverse function, I'm going to try to find some really good points. I see I have a really good point at -4. What's my scale? Oh, this is 2, so this is 1. So I have the f of x, make a table. I've got -4, -1. And then it looks like I have a point at -3, 2. 3. -2, 3. I'd really like one more point because I feel like otherwise I'm not going to know how to swoosh it in. Let me see if I can find another good one. This one's not so pretty. This one's not so pretty. Kind of looks like right here is nice, though. What is that? That's 5, 4. Okay, now I'm going to do the inverse in blue. So when I graph the inverse, I'm going to graph the points, -1, -4, 2, -3, 3, -2, and 4, 5. So let's get those points down. Let's see, we got, oh, this is going to be tight. I'm going to have to do the 4, 5 one first. 4, 5 is up here. Then I've got 3, -2. And I've got 2, -3. And then I've got -1, -4. I'm going to zoom out so I can see this whole graph. Oh, that's a little too small. That's a little too small. Let's try a different one. That's better. Okay. So I'm just going to keep the screen like this for a second. Because I have this point up here that's going to help me make my sketch. I know that it's going to come down like this. And if I think about the fact that this has to be a reflection over the line y equals x, which I'm just going to throw in here in orange. Here's y equals x. You can see that that really does fold nicely over the line y equals x. And if I had not put that other point there, I'll do it in yellow and then I'm going to erase it. Like if I had just tried to like swoosh it in like this yellow does not look like if I folded on the orange, it would line up with the original graph. So I'm really glad I got that extra point. All right, so now I'm being asked for some properties. The first thing I'm being asked for is the point of symmetry. I'm going to leave it zoomed out like this. Sorry if it's a little small, but I really want to see the whole graph. For f of x, the point of symmetry is here at -3, 2. The increasing interval, when I look at this, the whole graph does appear to be increasing. So I'm going to say all real numbers. You could also write this -infinity to +infinity. You could also write this -infinity is less than x is less than infinity. Now, for decreasing interval, this graph is always going up. So I'm just going to write none. For the blue graph, for the inverse, I've got a point of symmetry at 2, -3. And again, this graph is also always increasing. And you can use the same notation, but I'm just going to write all real numbers. I'm not writing all 3. And from left to right, this graph is never going down. Now, don't be put off by the fact that it kind of looks like it's coming down on the left side. When we read a function, we read it from left to right. And when I trace left to right, it's always going up. Okay. Number 6 has a set of problems asking us to solve each equation, and if there are extraneous solutions, to explain why. So let's get into it. Where's my, oh, there it is. Okay. So the first equation, to isolate the square root, I'm going to add 2 to both sides. Step 1, isolate the root. Step 2, get rid of the root. So I'm going to square both sides, and I've got 5x plus 11 equals 81. So again, isolate the root by adding 2, get rid of the root by squaring. Now I'm going to isolate the x. I'm going to subtract 11, divide by 5, and we end up with x equals 14. Now, it does say if there are extraneous solutions, explain why. I want to make sure that 14 is not extraneous, so I'm going to check. I'm going to say the square root of 5 times 14 plus 11 minus 2, and I want to make sure, is that 7? So 5 times 14 is 70. 70 plus 11 is 81. The square root of 81 is 9. 9 minus 2 is 7. All right, so that's a check. So this is a solution. As a reminder, you can use the scientific calculator for arithmetic. Letter B, we're going to start by isolating the root. So we're going to subtract, ooh, what the heck, man? Oh, jumpy. We are going to subtract the 12. Isolate the root. Get rid of the root. Square both sides. Isolate the x. I'm going to write this down. Isolate the root. Get rid of the root. And then check. All right, so we subtract 2 from both sides, and we get 23. Let's check it. So now I'm going to go the square root of x, oh, whoops, which is 23, plus 2, and that was originally plus 12, and the question is, will this equal 7? So 23 plus 2 is 25. The square root of 25 is 5, and 5 plus 12, the last time I checked, does not equal 7. Wah, wah. So this is a no solution. So if I see all this work, I can tell why. That's your explain why. Okay, that's fine. Now, if you stop here when you get to the square root of x plus 2 equals -5, and you just say no solution because you know that a square root cannot produce a negative number, you need to be like right here. I'll do it in blue. Right here, you need to say no solution. The square root of x plus 2, and you need to write all this out. So your choices are purple, solve all the way, check, and say no solution, or stop when you get here without the squares and give an explanation. At this point, you should pause the video and try C and D on your own. Okay, hopefully you pause the video. And I'm going to go first step. I'm going to isolate the square root. I'm going to subtract 13. Then I've got negative root 2x minus 1 equals 9. I got that negative. It's like a -1. So I'm going to divide both sides by -9. So now I've got the square root of 2x minus 1 equals -9. I have isolated the square root. Now I'm going to get rid of the square root by squaring both sides. Square the root, it goes away. Square the -9, it becomes 81. I'm going to add 1 to isolate the x. Always PEMDAS backwards. Always, always, always. We get 41. Let's give it a check. 13 minus the square root of 2 times 41 minus 1. And the question is this 22? This is 82. 82 minus 1 is 81. The square root of 81 is 9. 13 minus 9 is not 22. So sad. You could have, again, stopped right here with explanation, or if I see this, you can just write no solution, and as you know, I like to give it the X of shame. Let's give this one the X of shame. All right, last one that you should have already worked on by yourself is letter D. We're going to isolate the root. Well, what did the 5 come from? 14. We're going to get rid of the root. Square both sides. Then we're going to PEMDAS backwards to isolate the X. Then we're going to check. So my question is, does 6 equal 1 plus the square root of 14 times 2 minus 3? 14 times 2 is 28. 28 minus 3 is 25. Square root of 25 is 5. 1 plus 5 is indeed 6. So that's happy, happy. 2 is a solution. Make sure that you're not just taking notes, you're not just watching the video. Make sure you've tried them on your own. If you had to watch the video for most of them, I suggest you cover up your answers with a blank sheet of paper and try again.